Welcome to this presentation on formula, bonding, and the nomenclature. But before we proceed any further with this discussion, let's now have a concept on the valence. Dear viewers, what is valence? Valence refers to the ability of an atom of a given element to combine with other atoms. It is measured by the number of electrons the atom will gain, lose, or share in forming a chemical bond. A chemical bond is the force of attraction that holds the atoms together. Therefore, in general, we can define valence as the number of electrons an atom can share, gain, or lose in forming a chemical bond. And this can be discussed in relation to the periodic table as follows. For example, the elements that belong to group 1, that is hydrogen, lithium, sodium, and potassium, have only one electron in the outermost shell. Therefore, their valence is equal to 1. For example, lithium has one electron in the outermost shell. Therefore, valence is 1. Sodium has 11 electrons. The innermost shell is occupied by 2 electrons. The middle shell has 8 electrons. The outermost shell has 1 electron. Therefore, valence of sodium is 1. Group 2 elements, which are beryllium, magnesium, and calcium, all of them have 2 electrons in the outermost shell. For example, magnesium, which has 12 electrons, the innermost shell is occupied by 2 electrons, the middle shell is occupied by 8 electrons, and the outermost shell is occupied by 2 electrons. Therefore, the valence of magnesium is 2. And the calcium with 20 electrons, the innermost shell is occupied by 2 electrons, the second shell is occupied by 8 electrons, the third shell is occupied by 8 electrons, and the outermost shell is occupied by 2 electrons. Therefore, the valence of calcium is equal to 2. The elements which belong to group 3, that is boron and aluminium, have 3 electrons in the outermost shell. For example, aluminium with 13 electrons has 2 electrons in the innermost shell, 8 electrons in the second shell, and the 3 electrons in the outermost shell. Therefore, the valence of aluminium is 3. So, dear viewers, as you can see, the elements that belong to group 1, group 2, and the group 3 can normally combine by losing 1, 2, and the 3 electrons respectively to form the stable structures. So in this case, each element tends to form the stable structure of the nearest noble gas. Group 4 elements, such as carbon and the silicon, have 4 electrons in the outermost shell. Group 5 elements, such as nitrogen and the phosphorus, have 5 electrons in the outermost shell. Group 6 elements, like oxygen and the sulfur, have 6 electrons in the outermost shell. Group 7 electrons in the outermost shell of each element, such as fluorine and the chlorine, signifies that an element belongs to group 7. Therefore, as you can see, dear viewers, elements from group 4 up to group 7 They normally combine by gaining electrons according to the formula we are going to observe right now. Valence is equal to 8 minus n, whereby n is equal to the number of electrons in the outermost shell. For example, find the valence of element X, which has 17 electrons. Solution. Element X with 17 electrons has 2 electrons in the innermost shell, 8 electrons in the middle shell, and 7 electrons in the outermost shell. N is equal to 7. Valence equals 8 minus 7, which is equal to 1. Therefore, the valence of X is 1.